All right, we're asked in two different questions to find f prime of x when we're given capital F of x equals these different integrals. And so what we want to remind ourselves about is this rule. If f of x, capital F, is equal to the integral of, let's say, f of x, oh no, not f of x, sorry, I'll do the denominator, or not denominator, the lower bound h of x, upper bound g of x, of f of t dt, then, if we're asked to find the derivative of both sides, f prime of x will be the derivative of this, the integral from h of t to g, h of x to g of x, of f of t dt. And when we solve this out, this ends up giving us f of g of x times g prime of x minus f of h of x times h prime of x. And that should be an x there, sorry. And so this formula is something we're going to keep in mind, this idea, this concept of us finding this derivative. And so here we're given f prime is, we're asked to find what f prime is when f of x equals the integral from 0 to cosine x of 1 over t dt. And so the way we would do this, we know f prime of x is going to be equal to, and we're going to follow this rule. The first part is our upper bound. It's f of that, so I see f is 1, so 1 over, so it's going to be 1 over cosine of x times the derivative of cosine of x. And the derivative of cosine, we know, is negative sine. I would do the second part, but since we just have a constant here, we don't have to do anything else. This will just be our answer. And so we'll be given negative sine x over cosine x. You could end here, or you could go one step further and say that this is negative tangent x, because sine over cosine gives us tangent. All right, what about for question 2? Question 2, now we have two different functions. And so, for our bounds, I mean. And so, when we do f prime of x, we're going to first do f of our first function, so 5 times x minus 3 plus 2. And all of that times the derivative of our first function. But our first function is just x minus 3. The derivative of that is 1. And then we're going to subtract f of our second function plus 2. And that we're going to multiply by the derivative of our second function. In this case, the derivative of our second function is x cubed. And the derivative of that is going to be 3x squared. All right, so let's simplify this. 5 times x minus 3 is going to be 5x minus 15 plus 2. That times 1 doesn't do anything. Minus, this is going to be 5x cubed plus 2 times 3x squared. And so we're going to have to distribute that 3x squared. I'm going to free this out of the parentheses, 5x minus 15 plus 2 minus, and this we're going to have to distribute in a moment, but that first term I'm going to distribute there and then there, so 3x squared times 5x cubed. That's going to give us 15x to the 5th plus 6x squared. Now we distribute that minus 5x minus 15 plus 2. Negative 15 plus 2 is negative 13. Minus 15x to the 5th minus 6x squared. You could end here. I like to rearrange this just to make sure that it's neat and tidy. And so my final answer will be putting everything in order by the degree. And so I'm going to put the highest order polynomial first, or monomial first. Negative 15x to the 5th minus 6x squared plus 5x minus 13 is our final answer.